Barbonymus species is a ray fin freshwater fish genus in the family Cyprinidae that commonly found in all over Southeast Asia, like Indonesia, Malaysia, Thailand, Vietnam, and the Philippines. And scanning electron microscope (SEM) refers to the method of obtaining micrographs or images by scanning a high-energy electron beam across the surface of the sample. It is used to generate a detailed visual image of the particle with high quality and spatial resolution, as well as to study the surface phenomena of various material. The lack of study of the morphology and microstructure of Barbonymus species scale may lead to misidentification of species and misdiagnosis of population, as a lot of studies have focused on areas such as morphometrics and population dynamics. Other than that, Barbonymus species and freshwater fishes face more threat. Conservation is crucial since this species has been fished heavily and harvested, and as a result, it is crucial to put conservation measures into actions. Studies of this surface microstructure of fish scale is helpful in identifying major groups of fish and can even be used to identify individual species. This study will give an insight to help in maintaining the diversity of Barbonymus species. The objective of this study is to determine the microstructure characterization of scales belonging to Barbonymus species using scanning electron microscope. The specific objectives are to identify the morphological structure of scales of Barbonymus species and to differentiate the microstructure of scales between species Barbonymus schwanenfeldii and Barbonymus gonionatus using scanning electron microscope. 2 fish per species were utilized to ensure reliable microstructural data. The adult barb aged between 6 months to 1 year and were 20 to 35 centimeters long, weighed around 100 to 700 grams were used in this study. Fine forceps used to remove scales. After being removed, they were mechanically cleaned with a fine brush and rinsed with distilled water. The scales then were dehydrated and air-dried on filtered paper, and the scales were stored between glass slides for 2 to 3 days to prevent curling. The scale sample then were observed under 3 types of microscopes, which are stereo microscope, compound microscope, and scanning electron microscope to study the microstructures of the scale. Based on the general structure of Barbonymus schwanenfeldii, the scales on entire body were nearly round or pentagonal in shape. The anterior edge was curled in a wave-like irregular pattern, while the posterior was curved and semi-round. Visible appearance of radii. Focus structures seem unclear in the anterior or between the anterior field and the center of the scale. For Barbonymus gonionatus, the scales on entire body were round to nearly square or elongated in shape. The anterior edge was curled in a wave-like irregular pattern, while the posterior was curved and semi-round. Visible appearance of radii. The focus structure formed a point when it clearly converged the anterior field or scale center. The circuli of Barbonymus schwanenfeldii appeared thinner and flattened compared to Barbonymus gonionatus, which appeared thicker and sculptured. Circuli were distinct, although overcrowded in the anterior section, and almost widely separated in the lateral parts of the structure. The lapidans of Barbonymus schwanenfeldii appeared more irregular, uneven, and sharp-ended, while lapidans of Barbonymus gonionatus appeared more even and round, spherical-like in shape. The circuli and their lapidans, which are found in the anterior region of the scales, serve the purpose of anchoring and maintaining the scales in the dermal pockets. Additionally, the circuli and their lapidans serve as a friction pad between the anterior portion of the scale and the posterior portion of the anteriorly overlapping scale. This study on the scale morphology of Barbonymus species provide an illustration of the general characteristics that are found in various species of cyprinid fish such as focus, radii, circuli, intercircular space, and tubercles. Plus, the use of scanning electron microscope study on scales in 2 species of the Barbonymus species reveals that certain components of the scale and surface architecture between Barbonymus schwanenfeldii and Barbonymus gonionatus are different to some extent. It can be concluded from this that the use of scanning electron microscope to examine the microstructure of fish scales presents a variety of potential for detecting species specificity in fish. for taxonomic application as well as other significant uses. Due to the fact that solid scale samples are required for scanning electron microscope, the Barbonymus species scales were too thin and glass-like to examine. Therefore, it is essential to perform a few trials on gold coating that is fine enough for the scales in order to get scanning electron microscope micrographs that are incredibly clear. Plus, scale sample must be well prepared, such as completely dry and fit enough to be put inside the chamber.